Well, thanks for having me. I'm Jess. I'm a developer advocate with Launch Darkly. I am here to talk to you about tooling, teams, and this interesting study that I read on virtual teams and how team pairing relates to video games and what we can kind of learn from that and implement in our own sort of virtual teams now that everyone is quite remote first. So, when something goes wrong, is your first instinct to ask for help? Because you'd be forgiven for thinking that that is the way to get to your problem, to get to the solution to your problem way faster. Pair programming is often the way that we get unstuck. We always say two heads are better than one. We're used to these idioms, but it's not always the way to a quick resolution. If you played Age of Empires 2 or any of these kind of resource management style sandbox games, you might recall that a lot of the time, if you want to get something built quickly, you just assign as many villagers to a thing as possible. Just like with Lemmings, you have these small avatars, these small characters that only perform one thing and one thing well. But outside of the idea of like digital infrastructure or digital infrastructure itself, be that building a video game, things operate quite differently. And that's often because the work that we do requires handoff and exchange. Has anyone read the Mythical Man Month? Yes, okay, lots of people. And in the Mythical Man Month, they talk about the concept of a man month, which is. Please talk to me. Okay, a man month is the unit by which it takes a person to progress at a task. And it's almost like quite a fictitious unit. The idea that the number of people and the amount of time required for something to get done can be interchangeable as commodities is only true when a task can be partitioned among many workers with no coordination between them. Hence why the villagers in Age of Empires just simply get on with it. But when a task can't be partitioned, either due to its complexity or its structure, the application of no effort makes no real impact on the schedule. Software development, as we know, falls somewhere between these kind of two categories. You can partition the tasks, we can create user stories, we can divide things into smaller components and smaller batches, but we need communication and handoff between each subtask. Now, there are a few schools of thought around how the work involved in communication is distributed, and it's widely accepted that intercommunication is where the majority of the work lies. This is again another excerpt from the Mythical Man Month, if you recognise this graph. So if each part of the task you're working on requires one piece of handoff to be separately coordinated, the effort required to complete that section of work, it increases at a near exponential value when more than 2 to 3 people are involved. It just kind of goes off the charts. Kind of reminds me of department-wide meetings, right? Where the more people you get involved, the more work seemingly something takes. And this kind of marries with Brooke's law, the author of the Mythical Man. Adding manpower to late software projects only stands to make them later. So how do we get around this? Well, if we're speaking about laws, we can't gloss over Conway's law. And I'm sure everyone in this room knows about Conway's law, given that we're at Devox. Yes, okay, and Conway's law is? It's I was asking for that. Yeah, Conway's law is the idea that an organisation, the things that we make are the structure how we're structured impacts the products that we make. Let me go into this. So it was first observed by Dr. Conway, and the experiment that kind of brought Conway's law to life was when 8 people were tasked with creating 2 compiler projects. They separated into 2 different groups of 5 and 3, and each resulting compiler had the same number of phases as the people in that team. So it's kind of interesting how, even unconsciously, the number of people that we have involved in a project ends up bearing a fingerprint on what we eventually create. There are numerous examples of this in the DevOps handbook. And when you think of this law in the context of an entire company, it's no surprise that projects can become convoluted, unwieldy, and at times incomplete. The effect of organizational determinism introduces an interesting and difficult to resolve constant at play. So how can we design teams that aren't hindered by Conway's law? Well, I'm sure everyone here has also heard. I'm just going to keep telling you things that you already know. I'm sure everyone here has already heard of the two pizza rule. Yeah, it's the concept introduced by Amazon that every team should be small enough to be fed by two large pizzas. And rather than this being a unethical way to distribute pizza among people, it's the idea that we need to keep things small and autonomous. But the kind of issue here is that not every company is Amazon. Not every company has the resources that Amazon has and the structure that it has to kind of support this kind of working. So one of the first proposals, I'm going to try to get to the recommendations really quickly here, is define what small is and give it a value. In Team Topologies, another excellent book, they recommend the value between 5 and 9 for your teams. Giving this hard limit is really great because software gets complicated fast, as we all know, and things only stand to get more complex as we delve into them. And why is a specific number important? Well, Robert Dunbar, a British anthropologist, introduced the idea of Dunbar's number. I'm looking out for any nods, but this is the concept that we have, as humans, we have limitations. There is a hard limit of how many people we can form quality relationships with. And we can obviously recognize a great deal of people. We obviously have social media networks where we have 500 or whatever friends. We can recognize people, interact with a great deal more, but working relationships require really quality relationships and in-depth knowledge around how we work with each other. And what does this look like in practical terms? Well, lots of people use the squad model now. I think that's pretty standard. Ever since Spotify published the way that it produced software, squads have become super popular. But depending on what size of organization you're at, squads can kind of leave you pretty vulnerable to losing half of your dev team really quickly. So this is a solution to kind of create more feature-driven squads as things start to grow and you start to reach those upper limits of your teams. I'm going to go into why that's important now. So now that we've got our number of how big our team should be, we need to figure out who wins a spot on said team, right? We need to recruit effectively for that team. So that being said, anyone who's worked, so Patrick Dubois, he cites that silos tend to occur when teams become over-specialized. It can be so tempting to fill your team with a diverse set of specialists, each with their own area of expertise, almost like a heist movie. But the more specialized that these specialists become, the less of a shared vocabulary you have to work with. And that can really provide a bit of a bottleneck when it comes to communication. So the second recommendation I'm making here is to recruit people that are a jack of all trades and a master of some. They want to have a couple of really strong suits, but the ability to fit in as a generalist when needed. Now, obviously, not everyone can be a generalist. Everyone who's climbed a career ladder in a technology org will know that you need to define your niche as an engineer in order to get ahead. Working in these kind of smaller teams that kind of force you to be a little bit more generalized is a great way to kind of refine that muscle of continuous learning. Now, on that note, let's talk about the concept of collective intelligence. This is where the fun stuff gets involved. So collective intelligence is described as a group's capability to be able to perform a wide range of tasks and perform them well. Now, we found out over the past few years that it's possible for us to be all collectively uninformed. Kubrick stare at the news. But can we all be collectively smart? Well, there's this excellent study that was performed by MIT in conjunction with Riot Games back in 2017 that used a vehicle of League of Legends as a method of testing whether or not virtual teams paired based on their ability could outperform those with an in-depth understanding of each other's habits. And what they found was pretty astounding. This is only a short talk, so I'm going to gloss over some parts of the study, but if you hit me up on Twitter afterwards or LinkedIn, I'll give you a link to the study. It goes into a lot more of the pairing tactics, but just to give you a bit of an overview so you can kind of differentiate this from like ELO or like these kind of other kind of matching tactics and games. The idea here is to pair a group of 5 people who have a 50% chance of winning any given game. What the study found, oh, okay, so what does gaming have to do with work? Well, I mean, the teams, they need to make decisions really quickly in competitive environments. And if that isn't a technology company, I don't know what is. So the speed of decision making it's only standing to increase. We need to make decisions fast in order to stay competitive. So collective intelligence is important. And so when investigating the measure of collective intelligence, researchers found that a group's ability to be able to perform well at one task was largely transferable, meaning if they could do one thing well, they could usually do a variety of things well. And then secondly, the measure of a group's collective intelligence is impacted by both their individual attributes and the manner in which they're organised. So Conway's law does come into play here. Now, the things that make us collectively intelligent is a level of cognitive diversity. We all need those different sort of specialisms, large amounts of communication, and equally distributed communication. But the interesting thing here is that they noticed that the people that were, the teams that were the most collectively intelligent, they sent the fewest messages in the chat, and those messages that they did send were the shortest. So the gamers that knew what they were doing and that were performing really well wanted to spend their time in the game, they wanted to minimize context switching, and they wanted to do what they did well and spend their time effectively. Which sounds familiar, right? That's software engineering. So what does this mean in the context of a business? Well, this means that communication happens, but it doesn't happen in the chat box. As DevOps engineers, we know that we need to empower developers to be able to deliver software faster. We need to help them to minimize context switching. But we also need to make sure that we are advocating for observability measures, automation, but also metrics that everyone genuinely understands. So people don't just see alerts and start to have uninformed reactions to them. In practical terms, this means implementing measures like, say, Incident IO, a completely Slack-driven incident management system. Now, organizations, as the State of DevOps report author Nigel Kirsten says, they're people all the way down. And every year, we measure the most, what makes an elite performing company. And what's happening at the moment is, I don't know whether anyone followed last year's report. No? Well, so deployment frequency is obviously, it's always a really important metric. More elite teams are deploying software faster. But what's happening is the delta between the highest performing teams and the lowest performing teams is widening. More people are getting trapped in the middle. And a lot of the reasoning is because people are failing to define the interactions that they should have between teams and the order by which they should have them. So this is not really a DevOps problem, it's a people and organizational problem. And the issue is that often we either over-specialize our teams and don't put any thought into how they interact, or we do the reverse and put so much thought into communication and it becomes a massive silo that just, not a silo, it just requires a lot of work. This is where collaboration often happens in the sort of team topologies start recommendations, and it's quite like a light touch kind of segment. It doesn't kind of cross over in the same way a lot of the other teams do. So these observability measures and setting up tacit communication between teams can genuinely enhance the way that we work and make work a better place to be. Now, I'm going to push through the last couple slides here because I think I wrote this talk for the speaker that I want to be, not the speaker that I am today. So apologies for going quite fast. But this section kind of goes through the idea of giving your information a life cycle so that people can trust it a little bit more. All information will become out of date at one stage, and recognizing that and referencing that in the materials that you make is really important. It improves trust in the channels that we establish, and it kind of helps us overall. Finally, I think the last point that I really wanted to make was that, if we're trying to achieve organizational effectiveness, we often end up measuring these 4 metrics as outlined in the DORA report, is in the book Accelerate, and they're really excellent metrics. But the issue is that they are all impacted by our confidence. You know, if we don't trust the tests that we're running, if our tests are flaky, then we're going to distrust the code that we're deploying. We're going to deploy less frequently, and that's going to have a knock-on effect. So strengthening the integrity of the information that we store within our organization can actually help to create a better way of working. I am completely out of time, I'm afraid. So here's my TLDR. I have a list of resources. I have stickers, and if you email me, I can send you socks. So thank you so much for coming to this talk, and I really appreciate it. And look at this, we're back in a room. This is awesome. Hope you have a brilliant rest of DevOps. I'm going to wrap things up because I know we're on a pretty tight schedule today. So thanks very much, everyone. Cheers. Bye.